So you've learned about the units of pressure, volume, amount, and temperature, and also the two variable gas laws that relate two of the variables that are in the equation above. This equation combines all of the two variable gas laws into one, and this is called the ideal gas law. This equation relates pressure in atmospheres, volume in liters, amount in moles, and temperature in Kelvin. This only works when a gas is behaving ideally. So it works best when the temperatures are high and pressures are low. There's also a new constant here, R. R is the ideal gas law constant. The value of the ideal gas law constant is listed in your reference packet. It is 0.08206, and the units are liters atmospheres per Kelvin mole. Notice that the units for the ideal gas law constant match the ones for each of the variables that you would put in the equation. If you're given a value for pressure, let's say in millimeters of mercury, you would have to convert it to atmospheres before you could plug it into this equation and use that constant. Let's try this problem. How many grams of chlorine gas are contained in a 20-liter vessel at 115 degrees Celsius with a pressure of 18 atmospheres? We are going to use the ideal gas law to solve this problem. We already know R because it's a constant. The pressure given is 18 atm, and we don't have to convert that because it's already the unit that we want. The volume given is 20 liters, and again, we don't have to convert that because it's already the unit that we want. The temperature we have is 115 degrees Celsius. We can't use that as it is because it's not in Kelvin. To convert Celsius to Kelvin, you add 273.15. That gives us 388.15 Kelvin. Now we just have to solve for the missing piece. You can do your algebra first, or you can plug in first. It's up to you. I like to do my algebra first. I've divided both sides by RT so that RT cancel, and I've solved for N. Now I can plug in. Make sure you show your work and plug in your numbers with units. Also, make sure you follow order of operations. You need to multiply the two numbers on the top and multiply the two numbers on the bottom before you divide. So our calculator answer before we round it is 11.302, a whole bunch of other numbers, and the units are moles. You can do a unit analysis and see that liters will cancel and atmospheres will cancel and the Kelvin will cancel as well, and your units are 1 over moles, which is just moles. Now we have to make sure that we answer the question, because the question does not ask how many moles, it asks how many grams. This conversion should be very familiar to you. It's diatomic, so we need to double the mass on the periodic table, but we're converting moles to grams. Our calculator answer is 801.34 and a whole bunch more numbers, grams. If we want to be technical about significant figures, we have to round to only 2. Which gets a little tricky because we have to write it in scientific notation to express two significant figures. Bottom line, your answer should be about 800. And the units on your answer are grams.